Hello there. Hi again. This is Dr. Faisal. Welcome again to my lab. Today we are going to talk about one of the most interesting applications of the diodes, which you can find it everywhere in our daily life. And the application we are going to talk today is about rectifiers. And the most simplistic rectifier we have is the half-wave rectifier. Okay. I'm going to use this, this pointer to show you here on the bottom right the circuit for the rectifier. So basically we have an AC signal, okay, and followed with a diode in series with a resistance. And this is the circuit we are trying to implement here. And we are going to watch basically how the output voltage, V out, change with the input voltage, okay? So this is the schematic of the simple half-wave rectifier. And this is the circuit itself. It's in this side. Let me zoom a little bit for you. Okay, let me go a little bit down here. All right, so, okay, let's have a look. So as you can see, okay, so this tiny thing is basically the diode, this one, in series with this resistance and potentiometer here, which are shown in this graph, the resistance, okay, and the potentiometer here at a specific resistance. The values of the resistance are not really of great importance, and also the type of the regular diode we are using. Okay, so this is the diode we are using here. Let's see. Okay, good. See that? Okay, I shine now on the cathode part. So that's the diode in series with this, and this is the source. Okay, and the source of our voltage is this 2-volt peak to peak and 100 hertz frequency. Okay, good. All right, how is the rectifier is working? That's what I want to show you next. So we have talked about the schematic, the implementation of the circuit. Now that's where we plot both the input and the output. Okay, now I have to zoom a little bit here to see the stuff very well. Okay, good. So let me do that. Okay, there's some cinematic kind of things going on here. Okay, good. All right. I'm gonna switch gears on the other side. So watch me on the other side. Okay, good. All right, good. So let's see. So what you see here in blue is basically the input voltage. Okay, as you can see, so it's in blue. Let me change just the scale of this wave. Okay, all right. So what you see here in blue is basically the input voltage. Okay, so this is the input AC signal. Okay, and what you see here in yellow is actually channel. So the blue is channel 2, which is the input voltage, and the yellow one is actually the output, the out, as you have seen before. Okay, if we change the scale, the time scale, you can see that that the yellow, trust me about that. Let me change a little bit scale of the actually the yellow is very visible too. So the yellow one, which is the output, you see it's on here in the positive cycle. Okay, and so on the positive cycle, that means we're here and here, but here in between it's actually off. Okay, all right, so that's the yellow one. So the yellow is V out, the blue is V in. Now what you see in red here is actually V input minus V output. And why we want to do that? Actually, that's one of the core questions we want to discuss here. Okay, now let's zoom a little bit. Okay, see? Okay, all right, sounds good. So as you can see here, the output will not start unless the input voltage is above this limit. Okay, as you can see here. Okay, okay, and then the output goes on and on. As soon as the input voltage goes below this value, the output is back to off. Okay, and why is that? Because the rectifier, or the diode actually, here in this case, will not be on until the input voltage, which is the blue one, is above the barrier voltage. Very good. And what's the barrier voltage? Is actually the difference between the input voltage and the output voltage when we have an output voltage. That means when we have an input, when we have an output current, basically, okay? So when the diode is conducting. And you can see when we subtract the input voltage, the output voltage from the input voltage, here in between them, you see here, this red one, which is nothing but the difference between the two. You can see the source here. It's a mathematical equation here. We're applying on the input and the output voltage. See, it's constant here. And that value, let's go back and change the scale of that thing. Okay. Okay, now you can see that when they have all the same scale, and where is the scale is mentioned? It's here. This is the math function that we are applying, and this is the output scale, and this is the input scale. They are all of the same scale. And you can see that the output minus the input in this cycle is basically equal to the input, because the output is actually here yellow, 0. Okay, great. Not only that, the value of the difference between the input and the output, which is V naught, is equal to, let's see, is equal to, let's see, what is that? The cursor. We need the cursor. Where is the cursor? Here's the cursor. Very good. So it's equal to this value. You see this value here? That's where the cursor is, okay? So it's at 440 millivolt. And that's exactly the barrier of the diode, okay? That's what it is. So we have seen now this, and we know now the voltage barrier now of that diode is exactly at 440 millivolt. Now, let's do something a little bit interesting to see what our measurement of the barrier voltage last time means, okay? And here I have to take you to this experiment here, okay? Let me zoom out a little. So this is the same diode that we are using, okay? Okay, where is that diode? Let's focus here a little bit. Let's see. It's a bit hard to focus when you are the only director and the manager of your movies. Very tough. But let's see. So this is the diode. Okay, let's see now. Does it focus? Anyways, let's see. Try. Okay, good. Okay, anyways, so trust me, that's the diode we are trying to use, okay? And the using the method that I explained last time, what is that method? By using the multimeter with the diode port, you can see that the so-called barrier voltage is here, 0.58 volt. But what we have seen in the half-wave rectifier was 0.44 volt. So, which one to trust? What do we need to trust now is our circuit. That's what shows the... So what is really giving us with this value, okay, this thing? So actually this port is measuring the barrier voltage at 1 milliamp. And that's the reality, that's the truth, okay? Because the diode start to conduct, but then it will reach 1 milliamp after a certain voltage. And that's the voltage that you see here. So yes, this is the built-in or barrier voltage, but at 1 milliamp, okay? Is not the real barrier voltage. The real barrier voltage is what you see here, okay? It's this nice value in here that we got mathematically with this nice oscilloscope, which is what the cursor is showing there, okay? What's that? Zoom a little bit. 440 millivolt, okay? I hope you enjoyed this experiment of the half wave, and see you next time. Bye now.